In this college algebra lesson, we're going to be talking more about functions and their graphs. Please press pause and read the following objectives that we will cover in this lesson. All right, the first objective we're going to be covering is increasing, decreasing, and constant functions. So there will be intervals on graphs where the function may be increasing when you look at it from left to right. The graph may be decreasing as you go from left to right, or it may remain constant or horizontal as you read the graph from left to right. So I have examples on each of what this looks like. So the first graph over here on the left is going to be increasing. Notice as you look at the graph from left to right, it does increase. Some places more than others, but it's increasing the entire time. If you look at the one in the center at the bottom, that is decreasing as you go from the left to the right. The graph is decreasing at different rates, but still decreasing the entire time. And then the graph on the right is constant. It is not increasing, it is not decreasing, it is remaining a nice horizontal constant line the entire time. So if we look at this example, notice starting from the left on the graph, this graph is increasing until we get to this point right here, and then it starts to turn around. We'll be talking about those points in the next example. But from here, we are increasing, and again, that is from negative infinity, because right, this graph goes on forever. So from negative infinity up until we get to x value of -1. All right, then the graph starts to decrease, and it will decrease until we get to this point right here. So we have a decreasing section. Sorry for my scratching there. Writing on the computer screen for some reason makes my handwriting look horrible. And then we have from that point, keep going left. From left to right, it's now increasing again. So it's got another, you can write it separately, or you can just do a union here from 1 to positive infinity. It is increasing, or you could just write it again, increasing, and then write that interval again if you wanted to. So now let's talk about those points where it's turning around. Okay, those points we call relative maxima or relative minima. So when you start talking about calculus, you're really going to start diving into these, and there's a lot of cool stuff that happens at these points. They may be called local maximum or local minimum, depending on what textbook you use, but that will all depend on the textbook. So let's just jump right into an example. All right, identify the relative maxima and minimum for the graph. And that's the singular, by the way. Maxima, maximum, it's plural, but not that you guys care about that. Just those little things, that you might need to know. So right here, notice we have a point where it's turning around. It's increasing and now it's decreasing. So that point right there, that would be our relative maximum, right? And that is going to be that point which is -1, 10. All right, then the graph is decreasing, and then at this point it turns around and starts increasing again. And that point would be our relative minimum. Notice because it's lower, right? The taller one is the maximum, lower one is the minimum, and that would be 1, -10. So quite easy from the graph to find those things. And they will, in calculus, you'll talk about how do you find them algebraically, but we're just going to focus on the graphing part. All right, another thing that you can look at in graphs is symmetry. There are different types of symmetry that you could look at. So the first type is symmetric about the y-axis. So if you folded the paper in half long ways from top to bottom, if it's exactly the same on both sides, that would be y-axis symmetry. That just means algebraically that every point xy is the same as -xy. You'll have the point xy, you should have the point -xy. So algebraically, all you're going to do is substitute in -x into the equation, and it should still give you exactly the same equation when you clean it up and make it pretty. If you're doing symmetry about the x-axis, that means every point xy that you have on the graph, the point x -y should also be on the graph. So that means if you plug in -y for the equation and clean it up, you should still end up with exactly the same equation you started with. And the last type is symmetry about the origin, and that just says for every point xy that you have, the point -x -y would result. So when you're doing it algebraically, you would just plug in a -x and a -y together, and then when you clean it all up, it should be exactly the same equation you started with. So let's look at an example so we can kind of walk our way through this. All right, so here's our graph, right? This is our equation for our graph, and we're going to check each of those different types of symmetry. So let's start with the y-axis. So y-axis, remember, if we're doing y-axis symmetry, we're just going to plug in -x anywhere we see an x. So where there's an x, I'm going to put a negative x. Now, if we clean it up, do we get exactly the same equation? So negative x quantity squared is still x squared. So when I clean it up, I still get exactly the same. So that checks. We do have y-axis symmetry. All right, x-axis symmetry. This time it says take the equation, and every place there's a y, plug in a negative y. Okay, so instead of y, I'm going to put negative y. X, we're not doing anything with. All right, now clean it up. So I got to get rid of the negative sign in front of the y, and that gives me negative x squared plus 1. Notice that is not the same. So we do not have, this graph does not have x-axis symmetry. And then if you're going to check for symmetry about the origin, you're going to plug in both at the same time. So instead of a y, you're going to plug in negative y, and instead of an x, you're going to plug in negative x. Same time. Okay, then you're going to clean it all up. So let's clean up the x first. So negative x squared is still x squared minus 1, and then divide everything by negative 1, and I get negative x squared plus 1. So notice, again, this is not the same. So it does not have axis, or does not have symmetry about the origin. So this graph in particular only had y-axis symmetry and nothing else. It could have all three. That is possible. So make sure that you check every single type, because it could have all three types of symmetry. All right, another thing that we can talk about when it comes to odd or even functions, if we have an equation, do we know if it's odd or even? If the function is even, that means you can plug in that negative x, and it's going to spit out exactly the same equation. So that means it's got symmetry over the y-axis, right? If we plugged in negative x and it gave us the same thing. So even functions have symmetry with respect to the y-axis. Okay, if it's an odd function, okay, that means if we plug in negative x, we should get the opposite of the function itself. And another way that you can think about that is an odd function is symmetric with respect to the origin. So odd and origin, so that's one way you can remember. And then even is the y-axis. So it's just kind of nice to be able to have these other shortcuts that you can think about when you're thinking about graphs. So let's look at that example. Whoops, scrolled too far. There we go. Oh, nope, we already talked about that one. Oh, I scrolled way too far. Hold on. Okay, sorry, my mouse got a little bit out of control right there. Okay, so let's identify whether we have this function is even or odd. So again, or it might be neither. That's also a possibility. Okay, so you're going to plug in. So if you want to check to see if it's an even function, you're going to plug in negative x. So in our function, we're going to plug in negative x, and we're going to see if we get the same thing. Okay, so let's plug in negative x, and we get negative x to the 5th power plus 1. Well, negative x to the 5th power is negative x to the 5th plus 1, which that is not the same. So this is not an even, so it's not even. Okay, so let's see if it's odd. So if it's odd, that means we want both. We want h of negative x to be the same thing as negative h of x. So we just plugged in h of negative x over here, right? So we know that this side is going to be negative x to the 5th plus 1. Okay, so now we have to see, does that give us the same thing as the opposite of our function? So the opposite of our entire function. So I'm going to distribute that negative, and I get negative x to the 5th minus 1. And if you look, these two are not equal, right? So it is not odd either. So this function happens to be neither even nor odd. So that's another thing they'll be asking you about when they talk about functions. A special type of function that comes up is something called a piecewise function, and that literally looks like a Frankenstein function. It's got different bits and pieces that they just kind of shove together to make one function. So I like to call them Frankenstein functions. So let me show you some examples because I think it's a little bit easier. So this Frankenstein function they call c of g. It's equal to 40, so it's a constant function. If your g values are between 0 and 15, including 0 and 15. But if it's any g greater than 15, you're going to use this function instead. So it's just you have to pay really close attention to your domain values over here. They're really critical. All right, so find c of 5. Well, 5 is between 0 and 15, so that means we're going to use that. So that would have to be 40. Nothing for us to even plug in because it's constant. Okay, then it says find c of 50. Now 50 is larger than 15, so this time we're going to use this function right here. So that's going to be equal to 40 plus 0.6 times 50 minus 15. So just going to do order of operations. And inside the functions, 50 minus 15 is 35. And then 6.60 times 35 is going to be 21. And 40 plus 21 is 61. So C of 50 is equal to 61. So again, that would tell you that the 0.54 would be on the graph and the 0.5061 would be on that graph if you went and looked at it. So they're going to ask you to start graphing these piecewise functions. So let's do one of those. So here's the piecewise function. Oh, and let me move that graph down a little bit so you can actually see the rest of the function. There we go. All right, so notice it says if x is less than or equal to -1, it's just going to be the constant function 3. But if for any x greater than -1, you're going to use this graph. So I'm going to start at -1, and then I'm going to do some for x is less than. So I'm going to do some. So -1, -2, -3. Let's plug a couple in. All of those are just going to be a constant value of 3. Okay, so at -1, we're going to have the value of 3. At -2, we're going to have the value of 3. At right? Keep going, right? Forever and ever. But only starting from -1 and forever going backwards. Okay, now, when we have the point -1, any point greater than -1. So I'm going to actually plug in -1, but I'm going to make sure that I do an open circle right there because it's not including -1. So it's something very close to it, like -0.999999999. Okay, so we have to plug that in and then put an open circle there. So if I plug in -1, -1 minus 2 is -3. If I plug in 0, I get 0 minus 2 is -2. If I plug in 1, I get 1 minus 2, which is -1. So at -1, it's going to start at -3, but it's not going to include that point, right? Because there's no equal sign. And then 0, -2 would be right here. And then 1, -1 would be right here, and so on and so forth. And you could keep graph. You could do as many points as you wanted to, but so that is what the Franken function looks like for that one. Again, they're called piecewise. I just think Franken function sounds more fun. All right, another thing that you can do with functions is you can work with what's called the difference quotient. All right, this is the difference quotient. Again, you will talk more about this, especially when you start taking calculus. So you will hear about this again. But it's just this simple little formula. When they say the difference quotient, this is what they're talking about. F of x plus h minus f of x over h. Just give you a hint, it has something to do with slope, but you don't need to know about that right now. All right, so this says evaluate and simplify difference quotient. All right, so find and simplify the expression. Okay, so again, we're going to start with our difference quotient. So I'm going to write it down because I want to make sure that I pay attention. All right, so this is what we want. So let's start with f of x plus h. Sorry, I'm trying to get that out and it wasn't doing very well. Okay, the hardest part is finding this. Okay, that f of x plus h, that's the hardest part. So let's just focus on that for a second. So f of x plus h is going to be, again, everywhere we see an x, we're going to put x plus h. So I'm going to rewrite this whole function, but every place there's an x, I'm going to put a set of parentheses and put x plus h. And then there's a whole bunch of figuring this out, right? There's a whole bunch of algebra going on here. So we're going to have to multiply out this binomial, right? So that would be a perfect square trinomial, and that'll be x squared plus 2xh plus h squared. And then we would have to distribute that -2 that's in front of it. So that would be -2x squared minus 4xh minus 2h squared. And then we'd have all this other stuff. And notice you're not going to see a lot of like terms that you can put together, and that happens quite a bit. So just so you know that will happen a lot. Okay, so don't panic if you don't have a lot of like terms that you can put together. Okay, now let's go and do the whole thing together, right? Let's put the whole kit and caboodle together. Okay, so now that we know what that is, so first thing I'm going to have to do is rewrite that. Okay, so I know what f of x plus h is. Right, so let's rewrite that whole thing that we just wrote out from the last one. That's -2x squared minus 4xh minus 2h squared plus x plus h minus 5. All right, then it's going to have you subtract right? Subtract the entire function. So again, you're going to subtract all of that stuff. And then all of that's going to get divided by h. All right, but notice in the numerator that I can distribute, right? I can distribute this. So we're going to rewrite, and a lot of writing here, so I apologize. You'll find that some of these problems do have a lot of writing to do. All right, so this would be plus 2x squared plus x plus 5. And then again, all of that is going to be divided by h. All right, and then notice here we are going to have some stuff that's going to start canceling. So notice, or adding up to 0. So this and this add up to 0, so that goes away. The negative 5s, right? Negative 5 plus 5 adds up to 0. So you're going to see some things that start going away. Oh, and I forgot to look at me. I forgot to distribute my negative. Look at that. Listen, even I make mistakes. So everybody just note it. I forgot to distribute my negative here, and I forgot to distribute my negative here. So that wasn't very good. And this should be a positive 5. What am I doing? I'm having all kinds of issues. All right, so I'm going to press pause for a moment here. Not literally, but figuratively press pause. And just go back and fix all these errors that I had. I wrote down that was a negative 5 instead of positive 5. So I wrote that down wrong initially. And then I made the mistake over here. Oh, the good news is, though, these two will still add up to 0. So that's nice. And then we got the leading term right, so that was good. So again, I apologize but everybody's going to make mistakes. Please get used to that. Okay, so now that I've fixed all my mistakes, yay. Okay, now let's see what we have left. Oh, wait, I've got another thing that'll, notice that positive x minus x, that'll go away too. Okay, so that worked out pretty well. So notice all I have left now is negative 4xh minus 2h squared plus h. Everything else got taken care of. And then we're going to divide everything by h. And notice each one of these terms has an h in it. So I can divide out an h in each term. And that leaves me with that right here. So that is the difference quotient. Now, it just, again, make sure h cannot be equal to 0, very important. For now, you're not going to have to know anything more than just doing the algebra to get it there. Once you start taking calculus, we'll start talking about what that difference quotient is and how we can use it. But for now, you're just going to get introduced to it, and please don't make all the mistakes that I just did. Please be a better student than I was in that very moment. And hopefully we'll see you back for the next example.